Today we are starting a new chapter, Chapter 4, called States of Consciousness. This presentation covers circadian rhythms and how they regulate our sleep-wake cycle. Circadian rhythms are any patterns of behavior that synchronize to the 24-hour light-dark cycle of the day. In other words, any behaviors that go up and down or on and off in a regular pattern during one 24-hour day. And then that pattern starts all over again the next day. Your sleep-wake cycle is one of these patterns. For instance, you wake up at 7 a.m., stay awake for about 16 hours, go to bed around 11, and sleep for about 8 hours, and then wake up at 7 and the pattern continues. But our sleep cycle is not the only circadian rhythm. Body temperature, blood pressure, and sugar level also rise and fall in a predictable way over the course of 24 hours, only to start again at the beginning of the next day. So how does your body know what time it is? For your body to follow a predictable pattern of behavior over a period of 24 hours, doesn't it have to keep track of the time? I mean, how does your body know you've been awake for 16 hours and it's time to get sleepy and go to bed? How does it know that you've had 8 hours of sleep and that that's enough and it's time to get up? The answer is that you actually have an internal clock that tells time for you. Your internal clock is actually part of your brain that can detect the passage of time. How does it do that? What if I was to ask you what time it is right now, and you didn't have a watch or a clock or a phone? What would you do in order to estimate the time of the day? For one thing, you can always just look outside. Is it light out? Yes, then it must be daytime. Is it dark out? Yes, then it must be night. Our internal clocks use this cue as well. In fact, the clock in our brain receives direct input from the retinas of our eye. As light hits our eyes, that information travels into your brain to your biological clock, telling it that it is daytime. So where in the brain is this biological clock? It's in the hypothalamus. Remember, the hypothalamus is in charge of any bodily process that needs regulating. A process that follows a circadian rhythm, like your sleep-wake cycle, is one of many that have to be monitored and regulated. The biological clock helps the hypothalamus do just that. More specifically, your biological clock is in an area of the hypothalamus called the suprachiasmatic nucleus, or SCN. It doesn't actually look like a clock. I just used that picture to illustrate that the suprachiasmatic nucleus is the clock inside of your hypothalamus. Like I said before, input from the retinas in your eyeballs tells the SCN when it is daytime and when it is nighttime and helps your clock adjust accordingly. Without that light-dark signal, your SCN would not be able to regulate your circadian rhythms very well because your clock would start to become inaccurate. In fact, in research studies, scientists have shown that individuals that live in an environment where it is either completely light 24 hours a day or completely dark 24 hours a day will adopt a 25-hour sleep-wake cycle. And have you ever noticed how difficult it is to get out of bed when it is still dark outside? Our biological clock is saying, "Hey, what are you doing? It's still nighttime. Go back to sleep." We need the changing light-dark cycle of the day to help our SCN synchronize our sleep-wake cycle to the 24-hour day. What do you think would happen if I somehow removed your suprachiasmatic nucleus? Would you stop sleeping, or maybe you would sleep all the time? Actually, no. Scientists have done these experiments using hamsters. What they did was they removed the SCN of one group of hamsters, and they left another group of hamsters with their SCNs intact. Here's what they found. Normal hamsters that still have their SCN intact would be awake for about 13 hours and then sleep for about 11. This is pretty standard for hamster lifestyle. Looks very similar to the college student sleeping pattern as well, if you ask me. But look what happens to the hamster without the SCN. He has times when he sleeps and he has times when he's awake, but they are not in the normal circadian pattern. Instead, the hamster without the SCN sleeps in random bouts, staying awake for an hour and then sleeping for an hour and then awake for 20 minutes and then he sleeps for 2 hours, etc. When you remove the SCN, you don't take away the animal's ability to sleep, you simply take away its normal circadian sleep pattern. So what's a normal sleep pattern for human adults? It varies quite a bit from person to person, but on average, adults need about 7.5 to 8 hours of sleep per night to feel rested. Now, some people need more. For example, I really need about 9 hours of sleep to feel awake and alert the next day. But there are others that need less. I know a guy that only needs about 4.5 to 5 hours of sleep every night, and he's fine. Recent research indicates that young adults ages 13 to maybe 19 or 20 need more sleep than we previously thought. Indeed, about 2 to 2.5 hours per night more than the average adult. Surveys have revealed that most high school teenagers are definitely not getting the sleep that they need. Between school, extracurricular activities, work, homework, sports, in general, teenagers get far less sleep than they need to feel rested. How about you? How many hours of sleep do you need in order to feel rested? Which leads me to talk about what are the effects of sleep deprivation. We all lead busy lives, and when we are pressed for time, sleep is usually the first thing to get sacrificed. I've heard stories of students staying up 3, 4, even 5 days in a row. How can I determine the true effects of sleep deprivation? Well, one thing scientists know for sure. The one thing that will happen to all of us if we are sleep deprived is that we will get very, very sleepy. Indeed, sleepy, crankiness, and irritability are the most universal effects of moderate sleep deprivation. Also, poor memory and concentration, poor performance, even on relatively simple tasks, and poor decision-making and moral judgments. Basically, people who stay up all night, maybe students studying for finals, are probably not doing themselves any favors. Not only will they be tired and cranky, but chances are they won't perform very well under such conditions. Moreover, sleep deprivation is hard on the body, physically as well. Our immune systems become suppressed, making us more vulnerable to illness. On occasion, we may experience a disruption to our regular sleep-wake cycle. For example, when we travel, work the night shift, stay up all night studying, or maybe we just can't sleep one night and experience insomnia. Any of these circumstances throw off our internal sleep-wake cycle. Traveling to another time zone, especially one that is far removed from our own, can be especially difficult. About 10 years ago, I traveled to Hong Kong for my friend's wedding. Hong Kong is exactly 12 hours different from our East Coast time. So when it is 10 a.m. here, it is 10 p.m. there. My first week in Hong Kong was brutal. My biological clock was still synced with the old time zone, but I was required to get up and do stuff in the new time zone. At around 2 p.m. every day, I would get so very tired. My clock was telling me to go to bed because it thought it was 2 in the morning. However, slowly but surely, my biological clock began to shift to the noon time zone. So just about the time I was ready to come home, I was on the new time zone, which of course made it very difficult to adjust when I got back. So if you experience a shift in your clock for whatever reason, how can you go about shifting it back or resetting it to a normal rhythm? There are several things that you can do. First of all, you should sleep and wake up at appropriate times. Even if you are tired at 2 p.m., like I was in Hong Kong, try to keep yourself awake until your normal bedtime. If you sleep at inappropriate times, it will only prolong your problems. Next, make sure to expose yourself to the appropriate light-dark cues. If you are working the night shift, then try to make it as bright as possible when you wake up in the morning, even if it is still dark outside.